Here I am going to discuss the concept called context-free and non-context-free languages of the Model 4. Belongs to the session 4 of 18 CS 54. The under session 4, I am going to discuss the concept the following the way, that is uh, milestones we can see here. That is a presentation, the steps. So techniques for Turing machine construction, these are going to be one topic, and how to construct this Turing machine. So that is with a stationary head. It may be possible with a stationary head. The head will be fixed. That is that concept we can going to be extend to construct the Turing machine. The other way also, we can have storage in the state. So the states we can going to be stored in the memory. So that is also the alternative approach to construct the Turing machine for further discussion. The on the other hand, also we can discuss the multiple tracks Turing machine. So far we have seen that the Turing machine, deterministic Turing machine, and simple Turing machine, those are all encouraging for the single tape. There is an alternative, or the advanced or improved version of that is also called as a multiple tracks. We can borrow here. So we can adopt the multiple tracks, so that the infinite number of tape which have multiple tapes will be there, and the multiple head also may be required. So that concept also going to be discussed, is a part of that the technique to construct a Turing machine. So subroutine, there is also the subroutines are there. We can build a subroutine. The particular task we want to repeatedly we want to perform that. So in that case, the set of instructions, keep it in the particular small program, and that program we can call in the main program. The similar concepts we can going to be borrow here. That is a concept we can achieve with help of the what is called the subroutine concept. See, the subroutine concept we're going to be discussed in the presentation. Generally, the regular language, we have keep telling that it is evolved from the basic philosophy, that is the finite automata, the deterministic finite automata, that machine going to be accept the particular string, that is a star or a star b star. The star is the 0, 1, 2, or finite positive numbers may be going to be accommodated here. So such language is going to be a regular language which is going to be accepted by the finite automata theory. So having understood this, the context-free languages, so that is a non-deterministic push-down automata. So that is, for example, instead of saying a star in the regular language, now you can say a power n, or a power n and b power n. The particular strings are going to be accepted with this the non-deterministic push-down automata. In terms of the strings, we can say that w is the string, then the reverse string will be w power r. So this kinds of language is going to be represented with help of the context-free languages, as we discussed in the previous slide, also in the previous session also. So the eventually we can have that the Turing machine concept, so that is going to be accepted by the string, that is a power n, b power n, c power n. The multiple number of input symbols we are dumping into the taping, that is into the input set, that is a sigma, what we are one of the major tuple going to be addressed when you are talking about the theoretical computers, that may be finite automata, push-down automata, Turing machine, so on. That is, so now that is a set of inputs going to be increased. That is, multiple inputs may be possible here. So having understood this concept, we can go to the construction of the Turing machine with a stationary head. Right. So here we're going to be talk about the construction of the Turing machine with a tape head. That is. We can discuss, that is so that is going to be discussed here. The in the definition, we define delta q comma a as a q dash y comma d, right, where d is equal to l. D is equal to l, that is a direction. D is a direction. Some books refer direction left, right. So here the direction is a L or right. So the head moves towards the left or right after reading an input symbol, right. So in this case, the input symbol we have, that is a, right. So after reading or examining or scanning the input symbol a, the machine moves towards the left or right side. So that is a directions going to be tell. So that input will be replaced with the that is a y symbol here, right? So from this statement we can understand that stationary head, suppose we want to include the option, right? The options you can choice we can give, that is the head can continue to be in the same shell or for some input symbol, same cell for some input symbol. So that is possible here. So then we define delta q comma a, that is a transition q comma a. The q is a current state and a is the input symbol. The for the this kind of transition as q dash comma y comma s, right? Q dash comma y comma dash. So it current state is q and next state is q dash, and the input symbol a is going to be replaced with a y, and the s is stationary. Yes, is stationary. That is this means that Turing machine in on reading the input symbol a, changes the state q dash and writes to y in the current cell in place of and continues to remain in the same cell. So that after reading that symbol a remain in the same cell. So read for the next character. So that is a kind of stationary mechanism going to be imposed, that in terms of instantaneous description, that is WQAX, that instantaneous description WQ dash YX, that is. So Q dash input A will replace with the Y, and Q, the change of the state is Q dash. To remain in the same state, that will be, instead of saying q and q dash, we can say that w q dash yx. So thus in this model, delta of q comma a is equal to q dash comma y comma d, where d is equal to left or right. So that is a direction. So having understood these steps, the current cell, the writes the y in the current cell and remain in the same cell, for which you can say q dash. So the input a is will be replaced by the y. So this statement can tell about the stationary mechanism. So the other alternative, that is a storage in the state, using the storage in the state. So whether it is a finite automata or Fullstone automata or Turing machine, to remember the things. So irrespective of this philosophy, that classical the theoretical computer science computers, so that is things will be remember the things, that is device or exercise a state, employ a state to store a symbol as well. So the state becomes a pair, that is a q dash comma a, where q is a state in the usual sense, right? And is a tape symbol stored in a q comma a, right? So that is a pair going to be exercise for the transition, where q is a state and a is the tape symbol stored in a q comma a. So that is a semantics of the notations, that is a q comma a. So the new state of the states become q Cartesian product with the lambda, that is a tape symbol, right? That is one of the tuple we have discussed in the previous session. So that could be the Turing machine tape symbol. So that is a q comma q is a big q, that is a finite number of states which going to participate in the given diagram. So that Cartesian product of the what we called the lambda into q, that is a Cartesian product, the which includes the lambda, that is a input symbol along with the blank, right? So those could be become a vocabulary for that. Construct a Turing machine that accepts the language 0 1 star plus 1 0 star, right? So on exercise we can see that construct a Turing machine for 0 1 star plus 1 0 star. Solution: to construct the Turing machine for this symbol, for this string, the first symbol and checks that it does not appear afterwards in the input string, right? So does not appear afterwards in the input strings. So need two states, q0 and q1. To need two states, so q0 and q1. The tape symbols are 0, 1 and black, right? So these three symbols of the tapes. and states are Q0 and Q1. I hope you here following the nomenclature, which true states are Q0 and Q1, and input symbols are that is the tape symbols are 0, 1, blank. So the Turing machine having the storage facility in the state itself, is a see m is equal to machine is equal to Q0 comma Q1. So that will be represents the capital Q. Q0 and Q1 is a capital Q. The possible finite number of states going to be participate in Turing machine diagram. So that is a Q0 and Q1. And what are all the input symbol are that is a tape symbols 0, 1, B, right? 0, 1, B. The inputs are 0, 1 and 0, 1, B, and 0 that is a combination of that 0 and delta Q0, B, right? So delta Q0, B, that is a blank, and the Q0, B, B, Q0, B, that is Q0, B, that is. So that is a storage facility by the state. So in this initial state, M is in the Q0, Q1, M is in the Q1, and has been read the symbol B in its data portion. So on observing the first symbol input string from the set W, from the string W, that is a string W, machine moves towards the right side. Enters the state Q1 and first symbol, enters the state Q1 and first symbol, say A, it has seen. So the symbol A, it has seen, that is, right? So that way going to be represents that is storage in the state. So the other third possibility, that is a multiple track Turing machine, which help to construct the Turing machine. In the current case, that is what we are going to be present, the Turing machine defined earlier, single tape was used. Here multiple track Turing machine. A single tape is assumed to be divided into several tracks. So now the tape alphabet is required to construct a k tuples of a tape symbol, k being a number of tracks. K is a number of tracks. So that is a k tuples for the symbol, that is. So here hence the only the difference, the standard Turing machine and the normal Turing machine with the multiple track is set up tape symbols. So discriminate the standard Turing machine and traditional Turing machine with the many number of tracks. That is a set of tape symbols going to be addressed. That is, in this case, standard Turing machine tape symbols are elements from the dictionary, that is a lambda set. The tape symbols we can borrow from here. So that is a kind of a sump. It is there. It will be storing the input symbol, the tape symbols. So like sigma, which will receive the input symbols, right? This is will be a stack the symbols related to the tape, ultimately Turing machine. In case of Turing machine with the multiple track, it is that's a lambda power k, that lambda power k, because that k tuples will be there, k symbols will be there. The moves are defined in a similar way. So the movement of the head will be moved in the similar way. Coming to the other concept, so that is called the subroutine. The subroutines are used in the computer languages, right? Subroutines are used in the computer languages. So when some task has to be done repeatedly, right? So particular task we want to repeat for the particular piece of computations, will perform some certain instructions which kept in the some loop, right, within the loop. Also from Turing machine as well, right? So this can also perform by Turing machine. The first Turing machine program for the subroutine is written, right? So this will have as an initial state, A return the state, initial state, and A return the state, that is. After reaching the return state, so after reaching the return state, there is a temporary halt, right? So the ad hoc halt will be there. So after reaching the return state, so there is a temporary halt. For using subroutine, the next states are introduced. For using the subroutine, next state is going to be device, that is. So next state going to be initiate. When there is a need for calling the subroutine, when there is a need for calling subroutine, moves are affected to enter the initial states for the subroutine. So need for whenever necessity of subroutine application, or we can call them. So call the subroutine. So and moves are affected into initial state for the subroutine, and return to the main program of Turing machine. So return to the main program, the Turing machine. So design a Turing machine which can multiply two positive integers. So we can observe a effort here. Construct the Turing machine to multiply the two positive integers, right? So there are steps we will going to be follow. So let we consider 0 power m, 1 0 power n, 1, right? So 0 power m number of zeros and followed by 1, and n number of zeros and followed by 1 is placed on the tape. That is, the output will be written after the rightmost 1. Right. So the leftmost is a 0 is erased. The leftmost is 0 and rightmost is a 1. So that strings we can observe here. So a block of n zeros is copied onto the right end, right? So block of n zeros copied onto the right end. Then the step 2 3, the second step and the third step, 0 is leftmost 0 is erased and block of zeros are copied into right side. Step 2 and 3 are repeated m times, and 0 power m and 1 0 power n is obtained on the tape. So 0 power m and 1 0 power n is obtained on the tape, that is. So the prefix 0 power m 1 of 0 power m and 1 0 power mn is erased, right? So the prefix what we have, 0 power m and 1 of the 0 power m and 1 0 power mn, right? 1 0 power mn, that is. So is erased, leaving the product m into n as the output. For every 0 in a 0 power m, for every 0 in a 0 power n, that is a m zeros, 0 power n is added onto the right end. 0 power n is added onto the right hand. So here this require a repetition of the step 3. This require a repetition of the step 3. So here subroutine we can make it use. So that subroutine is a copy. COPY is a subroutine for the step 3. So not to perform step 3, so that we are going to be hand out to the subroutine. So that subroutine name is called copy, COPY, for step 3. For the subroutine copy, the initial state is Q1. Initial state is Q1 and final state is Q5, right? So here we can observe that the states are going to be participate. So tape symbols are 0, 1, 2, blank, right? So 0, 1, 2, blanks. We can consider that. So having followed this, the initial state is Q1. When you write an initial, the input is 0, then it will go to the Q1 to Q2. Q1 to Q2, and 0 will be replaced by 2 and move towards the right side. Similarly, when the tape symbol is 1, it go to the next stage called Q4. 1 will be replaced by 1 and move towards the left side. Move towards the left side. When 2 and blank are not answerable, so at Q2 and 0 is there, it remain in the same state and replace with a 0. 0 will be undisturbed and to move towards the right side. Similarly, when you read Q1 and remain in the same state and maintain the same data and move towards the right side, and when you do not necessary to answer that, and Q3 Q3 B will be replaced by 0 and move towards the left side. So similarly Q3 is a current state, Q3 0 input and replace with a 0 itself and move towards the left side. Q3 1 will be 1 and move towards the left side. When you 2 at Q2, when you read 2 input, then will be remain in this it move towards the Q1 state and 2 will be remain as it is, move towards the right side, and B is not applicable. And similarly Q4 only one we need to be respond, that Q5 is a final state, is 1 will be there and move towards the left side, and Q4 0 will be there and left time. So the Q5 is a final state. So having understood this, what is called transition table, so Turing machine model has the initial state Q0, the initial ID, that instance description for the m is a 0 power m and 1 0 power n and 1. On seeing 0, the following moves take place. Q6, right? Q6 is a state of the machine of copy, that is. So here we have what is called instantaneous description. We can apply m Q1 0 power n 1 ID. We can have 2 that is 2Q2 0 power n minus 1 1. Then ID, number of IDs we can exercise. So we can have 2 0 power n minus 1 1 Q3b instantaneous description, that is a 2 0 n minus 1 Q3 1 0. So ID star, that instantaneous description, so we can have that is a 2 Q1 and 0 power n minus 1 1 0. So the Turing machine M1 performs subroutine copy. The following move take place for machine M1. So Q0 0 power m is 1 0 n 1, that is a input Q0, and let's go to the Q6, that is a replace that 0 by blank and 0 power m minus 1 10 power n and 1, applying instantaneous descriptions. So the B0 power m minus 1 Q6 1 0 n 1 and B0 m minus 1 and 1 Q1 0 n and 1. So that is going to be continue here. After the exhaustive zeros, Q1 enters to 1, M1 moves to Q4, that is all 2's are converted back to zeros, and M1 halts in Q5. So Turing machine it collect the computation by starting from Q5, picks up the starting from the Q5. The Q0 and Q6 are the states of the machine. Additional states are created to check. The additional states are going to be created to verify that the each zeros in a 0 power m gives rise to 0 power m. So each zeros of 0 power m is yielded to 0 power m at the end of the rightmost one in the input stage. So rightmost one is the rightmost the one is there. So once this over, m erases 1 0 power n and 1 and finds the 0 power n into m, right? 0 power nm in the input tape. The machine can define by delta, that is a transition table will be there. So we can have m is equal to q0 comma q1 comma q2 comma q12. So that is a 0 comma 1, and input same tape symbols are 0 comma 1 comma 2 comma b, and delta q0 comma b, and that is a q12. From the table we can understand that. So here we have q0 for the input 0, Q5 B6 is Q6 B6 and not respond for except 0. Q6 is a Q6 0 will be 0 and right move to right side, and Q6 to Q1 when 1 appear, as the input symbol, keep move right side and maintain the 1. Q5, that is a Q7, 0 to move towards the left side. And in the case of one input Q7, it go to the changes the state Q8 and 1 comma L, and Q8 is a Q0 L, and Q10 when the blank symbol is red, that is a Q10 B comma R. And we have that is a Q9, that is a Q9 is a 0 comma L. When you read 0, 0 will be maintained more towards the left side, and B, that is a B is there, we can be that Q10 is a Q11 B comma R, Q11 B comma R, that is, so that Q11 when 0 is there, Q11 B comma R, then 1 will be there, because that string will be ended with the 1, so that is a 12, so Q12 B comma right, more towards the right side. So this performs multiplication of two numbers unary representation. So after discussing this problem, so we can discuss one more, the construction of Turing machine, that is a 0 power n and 1 power n, that is going to be what is called n, that is n is greater than or equal to 1. So construct the Turing machine that accept the string, particular string, that is having a finite value of the n. So input symbols are 0 comma 1 comma x comma y, that is a b, right? So after reading zeros and 1, those strings were going to be replaced with a x and y. 0 is x and 1 is y, and b is a tape symbol. So initially we can consider that at beginning q0, and going to be next state after reading the 0, delta of q0 comma a is equal to q1 comma x comma r. What is that meaning? Input 0 is read, and that going to be replaced with a x, and change the state q0 to q1, that is a next state, and move towards the right side. So in 1 and x no response, so when you y is there, so y represents the 1, right? When y appears, so q3 comma y comma r, so it changes state and move towards the right side without disturbing the y. You can keep that is. So next q1 is a current state now at the second iteration, at the second row of this transition table. So q1 will be remain in the same state and read the 0, that is move towards the right side. When the input 1 appears, so that is going to be replaced by y, right? So in the earlier case, when 0 appears, it replaced with the 0. Now 1 appears, it replaced with the y, q2 comma y comma l. So q1 comma when y appears, so that will be maintained as it is. Only 1 appears, it change the y, and y appears, it retain the same. Then 0 appears, it change the x, and x appears, it retain the x. So in that fashion it will go, that is. So we can have q2 is a 0, input symbol delta of q0 q2 comma 0 is a q2 comma 0 comma l. So when 0 appears, retain the 0 and turn the read write head towards the left side, right? Read write head left side. So x appears, so keep move towards the right side, still some more x will be there, q0, only it changes to the q0. And when y appears, it go to the q2 will remain same, q2 comma y, delta of q2 comma y is nothing but q2 comma y comma l. So y will be as it is, move towards the left side tape, and state will maintain the same state. So coming to the q3, so q3 we have to address only the y, q3 comma y comma r. So when blank appears, so q4 comma b comma r, right? So change the state, maintain the blank, and do the r. Q4 is a none will be respond. So Turing machine basically matches up to zeros and ones. Q1 is scan right state, Q2 scan left state, so Q4 is a final state. So Q1 to move towards the right side and Q2 move towards the left side. So both are attacking both side, and finally it's to the final state called Q4. So that is a 0 power n and 1 power n going to be when n is equal to 0, 1. So continuation of the similar example called a power n and b power n. So a power n and b power n, here going to be discussed, that is construct a Turing machine to accept the string, that is right. So here initially, so this is a state diagram approach. So earlier that is a transition table approach. So state diagram or transition table, transition diagram or transition graph. So more or names will be there. At Q0, Q0 is a current state and input is a. So this is a n A's are there. The first A we can consider. So then A will be replaced with the X and tape will be moved towards the right side and going to the next state, that is right. So going to next state, that is, so tape will be this side is the left side and this side will be right side, that is. So input, let consider example 3A's and 3B's. The input string A power 3 and B power 3 consider. So A power n and 3 power n. So 3A's will be there and 3B's will be there. At the rightmost, the blank B will be there. That is a tape input symbol, right? So we have built the foundation for this proceeding toward the solution for this problem. So begin with the Q0 state. So the essential document we collected here. So when Q0 read the input symbol A, then move towards the right side by replacing the X, right? The first X, the first A will be replaced, the first X will be replaced here, right? So the first X will be replaced here. So next we can go to the scan all these A's and search for the first B, right? Search for the first B. So when you reach to the Q1 state, so here we can, the possibilities are there. So there is a may be possible, right? So because first A we read, no, the second A may be possible now. So second A, in that case what will happen? We undisturb that A, second A, or it becomes like a third iteration, third A, fourth iteration, fourth A, like that. At now at this junction we are pointing to the second A. We are talking about the second A, right? So second A will be replaced. It will be remain as it is, retain as it is, and tape will be moved towards the right side. One possibility. So other possibility, if we have already the second and third, fourth iteration, so then we will be encounter the Y, right? So because Y won't be replaced with the B will be replaced with the Y as we did A in the A, as we did the X in the A, right? X will replace the X, A will be replace the X, similarly B will going to be replace the Y. So if we have already done so, then we have to maintain that and move towards the right side. So these are the two possibilities remain in this Q1 state, right? So I hope it is crystal clear from this the discussion. So moving from Q0 to Q1, so when the first A read, and next A we are reading, then remain in the same state. Similarly, Y you are reading, remain in the same state. So now going to be the blank. The other possibility is blank, right? After reading n A's and n B's, so we definitely encounter the blanks, right? After reading that blanks, if it is a blank is there, then replace with the Y also. Replace with the Y also. Then turn the finite control read write head towards the left side. Towards the left side to read the assume that we read first A and first B. Then we have to come back to read the next A and next B. So in that case we should turn back to left side. So now before turning, that is the blank will be replaced, so that is a B will be replaced with the, so that is a B, that is not blank, that is a B will be replaced with the Y, right? First B will be replaced with the Y, as first X replaced with the first A will replace with the X. So as first A will replace with the X, now the first B will be replaced with the Y, right? So this process will be going to be continue. So that is X will be the when at Q2 you are reading the X, then X retains and